metal atoms. Remember I went over this earlier. Balance O, use H2O. Balance H. Balance charge. Use electrons. And that's the thing we want to find out is how many moles of electrons we need. Okay. So the first part of this problem we just saw a minute ago. That's going to give you the moles of electrons. Okay. So we have I 3.25 coulombs per second. Here you have to convert that to seconds, so it's 2 times what? 2 times 3,600 plus 25 times 60. Everybody knows how to convert hours and minutes to seconds, right? That's the easy part. This is the tough part of the problem right here. You want to deposit the metal, so that's what you're going to end up with is just elemental rhenium. Next you balance the oxygens. Then you balance the hydrogens. There's 3 and there's 24, so you have 21 H pluses. And then you want to balance the electrons. The charge on the right is 0, so you need what? 21 electrons on the side. So there's for this half reaction, if I take the atomic weight of rhenium, which I gave you in the problem here, divided by 7, I reduce the fraction. It gives me the equivalent weight of rhenium. Okay. Now your book sets it up in this format. He gets, this is the charge. He divides by this number of moles of electrons times atomic weight. Okay. As I said, I only wrote it in this format because I talked about the equivalent weight in 1A. If your instructor didn't do that, don't worry too much. This textbook doesn't. But it's a concept that comes and goes. If you're doing quantitative analysis as your next course down the line, you'll see more about equivalent weight. Okay. But that's basically the problem. So you know the current, you have to be able to convert the time to seconds, no big deal. This is the tough part, getting the number of moles of electrons per mole of metal. Okay. That's all there is to the electrolysis problem. There's nothing else to do with it. I was really generous. I gave 5 points to the problem, maybe 1 or 2 points. Okay. This is the KSP problem with the concentration cell. We did this one. This one, notice I gave 6 points here. I gave you the same problem this semester. I give you 2 points because I already talked about the equation, right? But you used to solve this problem. You forgot it already. I wonder if I asked that on the quiz today. What do you use to solve this problem?
Oh, pH?
pH, right? Gave you the cell potential. And what did I ask you for? What is the pH? That's why it's only worth 2 points. Before, when I gave that quiz, I hadn't talked about it in lecture. I just gave the quiz to let people figure out that relationship, which I did for lecture.
What is that relationship?
What is what relationship? This relationship.
Did that?
And what I got that from was what?
Yeah. It's on the video. Yeah, it is.
Oh, okay.
I have a mostly videotape. That's on YouTube. I have that big part of it, actually.
In other words, I went through the Nernst equation and I wrote this reaction H plus, more concentrated, goes to H plus dilute. And the more concentrated was 1m, so the denominator here was 1, everything is squared, and this was a 2, and they cancel out. So basically, just because we're working with the equation, what? That equation. 2 moles of electrons, and when you do that, it's H plus squared in the numerator. Or to balance this equation, then n is 1, n is 1, and it's H plus to the first part, which is what you get when you reduce it down. So you eventually ended up with this equation, which I did for you in lecture,
Yeah.
and the book does that for you. And I said, when I gave this quiz, the reason it says 6 points, and we get the same question on a quiz this semester is going to say 2 points, is because when I gave that quiz, I didn't go through this, I let people read it in the book, or they had to figure it out themselves. Okay. What else is there? Oh, draw the structure, and we're getting to organic chemistry. I'm done with electrochemistry. Any questions about electrochemistry? I've covered all the topics. This electrolysis thing is the last thing, and this is what you need to know. So if we're all done with that, no questions, a couple more. Yes,
Yeah, can you go over how to balance that equation?
which one?
This one? Yeah.
Right there. Okay, first of all, this is the thing he gives you way back in chapter 5 on how to balance half reactions. Okay? So let me write another equation. I guess I don't have another one written. Sometimes I have the same things repeated. But I started with this formula. There it is, right? And the first step says balance everything except hydrogen. The only other thing is rhenium. Now rhenium's balanced. Okay. Then the next step is balance the oxygen using water. There's no water here, there's 12 oxygen, so I need what? 12 waters. Now I've got 12 oxygens on both sides. Then the next step says balance the hydrogen using H plus. Well, there's 3 H pluses here, 24 H pluses here, so I need what? 21 hydrogen ions. Now I've got 24 hydrogen, 24 hydrogens. Last step, and this is the thing you need to do, you got to get the number of electrons, right? So basically, this side has 0 charge, this has 21. If I put 21 electrons over here, now we have 0 charge on both sides. It's that same problem I was talking about a few minutes ago. One of the important things throughout chemistry when you're getting these net ionic equations is that you always have charge balance. And we use the charge balance in this particular instance to figure out how many electrons we needed to reduce the rhenium in this, I guess it's a complex acid, because we certainly never saw that acid before. If I had been fancy, it would have been what?
Brackets.
Use the bracket in there. But it was fancy, I just took the whole thing. But can we name it? can. You'd say what? You start off with this, go, Deca, Oxo, R-H-E-N. And the reason I could write 7 down is because that's what I figured out here when I divided out the oxidation state. When I figured out the oxidation state of the reed. And he changed the ATE to an IC and doing acids. That was all back in that nomenclature rules. I probably won't ask you. But I just thought I'd remind us about something we did before. So anyhow, is there any other electrochemistry? Because I'm ready to start talking about organic chemistry.